All right, so for the cotangent function, we're going to use the same process as we did for tangent. Remember that cotangent now is defined as cosine over sine, meaning whenever sine of x is 0, the cotangent is going to be undefined. So let's think about when sine of x is 0. If we're on the unit circle and sine or cosine are 0 only at the quadrantal angles, right? So here at 0 degrees, x is 1, y is 0. This is 0 and 1, negative 1, 0, 0, negative 1. If sine is the y-axis, then it's 0 here and here. So at 0 and at pi, sine is 0. Yes? That means cosine over sine will be 0. Will be undefined. So at this point, when the angle is 0, cotangent of 0 will be undefined. Cotangent of pi will be undefined. Are we okay with this? So cotangent is undefined wherever sine of x is 0. At these points, it has a vertical asymptote. So for example, for the cotangent, the vertical asymptotes are at x equals 0, pi, and 2 pi. Where were they for the tangent? Negative pi over 2, pi over 2. So at all of the half pi's, right? 7 pi over 2, 9 pi over 2, and so on. The cosine is, the cotangent is going to have asymptotes at the full pi's. Okay, so at negative 9 pi, at positive 32 pi, at 2 pi, at negative 3 pi, at 1 pi, at 0. Okay? Yeah.
When the asymptote is in the screen tells it when the asymptote's on 0, like on the y-axis, should we draw both like the dash
Yes.
line and the...
Yeah, just make it like adjacent so I can see. Okay. All right, so if you look at the graph for the cotangent, then at first glance, it looks very similar. The first cycle, that initial cycle, is from 0 to pi, right? So it's from 0 to pi. For tangent, it was from negative pi over 2 to pi over 2. This one is from 0 to pi because that's where our asymptotes are. So the period has a length of a pi, just like the tangent. So lots of similarities between tangent and cotangent. And then some differences as well. Now, so the orientation, though, is a little bit different. So let's see how we can wrap our head around this. If we start right after 0, right, this is where we have, if that's pi over 2, then this is pi over 4. Is that right? Then pi over 6 is here, and pi over 3 is there. Okay? So when we look at how this is the same as what's on the unit circle. If this is 0, and this is pi over 2, this is pi over 4, pi over 6, and pi over 3, right? Okay, so do we see that this corresponds to the first quadrant on the unit circle, right? It's the same angles here as the first quadrant on the unit circle. On the unit circle, in the first quadrant, is cotangent positive or negative?
Positive.
Positive. That means on the graph, for the angles where it corresponds to the first quadrant, cotangent is going to be positive above the x-axis. Okay, so this is how I can wrap my head around it. Because when I'm graphing, how am I supposed to know if it's going to go that way or that way? Well, if this is the quadrant from 0 to pi over 2, then I know that from 0 to pi over 2, cotangent is positive. It must go above the y-axis. All right? Okay. Everything else is pretty much the same as the tangent. So let's go and see how we're going to set up our inequalities and how we're going to figure out where our asymptotes are. The vertical asymptotes happen, remember, at x equals 0 and x equals pi. So in order to solve for the asymptotes, we have to set the term bx plus c equal to 0 and equal to pi. All right? Okay, so which means if we have a period that is different, we're going to solve this inequality. So now we have now we have three variations. For sine and cosine, the inequality goes from what to what?
0 to 2.
And for tangent? Negative to positive pi over 2. And for cotangent? 0 to pi. Okay? So here, since there is an asymptote, these are going to be just less than. All right? Okay. So let's go with this one. So here we have y equals cotangent of 2x. We want to find vertical asymptotes and we want to sketch the graph. All right. The period, remember the default period has a length of pi. So it's always going to be that over b. In this case, it's what? Pi over 2. That means from the beginning of the cycle to the end, it's going to span a length of pi over 2. Okay? All right. To find the asymptotes, we're going to solve that equality. So 0 to pi, and inside I put in my 2x. 0, x, pi over 2. So do you see how we use that for all of them across the board? This is why the first day when we start graphing sine and cosine, I do go a little bit slower. I spend way too much time on that one because once you learn that, you're going to carry it with you the whole time. If you're confused on the first time, then it just carries through that way, right? Okay, so from 0 to pi over 2, that means my asymptotes are at x equals 0 and x equals pi over 2. Remember, never just 0 and pi over 2. It's an equation of a line. All right, this is my x-axis. And I say, all right, 0, 1, 2, 3, 4, half a pi. Okay, now the midpoint, the very, very center. So always figure out what is this the center of, and then you take the two endpoints that have to be equally far away from the center, add, divide by 2. This is the center of 0 and pi over 2. That's what I take. I add, divide by 2, and what do I get? Pi over 4. Here, okay, that first one in this green, now, that's the midpoint of 0 and pi over 4. I take those two, add, divide by 2, and I get pi over 8. And now I'll do the next one in red. That's the center of pi over 4 and pi over 2. So what I'm going to do is I'm going to take those two, pi over 4, pi over 2, add, divide by 2. Okay? So how much is that? If it's pi over 4 and pi over 2, 3 pi over 8. How else could you know that? If it starts with 0, each one of these are the same increment, right? So if this is pi over 8, another pi over 8, another pi over 8, this is 3 pi over 8. So there are lots of ways. This is why it's so much fun. Okay, now, here we have our y-axis. Okay, the y-axis also corresponds to an asymptote. So if I'm using a pencil, it's okay. I could just make the asymptote adjacent to it. Just make it visible. Students are usually okay with that. Okay, the center is always going to be at on the axis unless there is a vertical shift. And now, this initial part remember, corresponds to the first quadrant where cotangent is positive. And as long as A is positive, we're going to go up. So here it's going to be up the same value of A. If A is 1, I go up to 1. And then here I need to make it symmetric. We're going to follow the asymptote. Boom. There. Okay? Correct. It looks like a tangent. So what Rachel said is it looks like a tangent with a reflection around the x-axis. And there's also a shift because that used to go from 0 to pi over 2. Yeah. Let's do secant and cosecant. Okay, so remember what cosecant and secant are. Cosecant is 1 over sine, and secant is 1 over cosine. That means whenever you have a rational function, whenever you have variables in the denominator, that's potential for, not potential, like that is going to be a vertical asymptote. Wherever the denominator is 0, you're going to have vertical asymptotes. We just said up there that sine of x is 0 at what? X equals 0, pi, and so on. Cosine of x is 0 at x equals plus or minus pi over 2, and so on. That means cosecant must have asymptotes wherever sine is 0. At 0, at pi, at 2 pi, at 3 pi, negative 3 pi, negative 5 pi. Secant is going to have asymptotes where cosine is 0 at all of the pi over 2's, just like the tangent, right? Now, the difference is, all right, different from tangent and cotangent, is that cosecant has minima where sine has maxima, and vice versa. Okay, so you can see the graph here. Look at the dashed line. That's the sine graph, correct? And we know that sine, at some points, it's 0. At other points, it has a minimum and a maximum. And we've said this from the very beginning, that the graph for sine and cosine oscillates around the axis between minimum, maximum, and 0. So, where sine has a maximum, okay, if it's the largest number the sine can reach, so like 5, 1 over 5, that's going to be the smallest number that the cosecant can reach. So where sine has a maximum, cosecant has a minimum. Where sine has a minimum, cosecant has a maximum. At the end of the day, this is how it looks. It's the inverted version of the sine and the cosine. Do you see that? So between each pair of asymptotes, we take the sine or cosine graph, and then you invert it, and it's going to follow the asymptote down or up. So essentially, the way we draw these is, we draw a cute little sine or cosine graph, and then we match these according to it. Okay? So similarly then, secant has asymptotes and minima and maxima, where the other one has, it's flipped. Okay, because they follow the same pattern as the sine and cosine, the period for secant and cosecant is 2 pi.
Always.
Always. It's the same as sine and cosine. So the period for both secant and cosecant is 2 pi over b. And the asymptotes are where the sine and cosine are 0. Okay? All right. So what we're going to do here is we're going to use the graph of 2 sine 2x to graph. These should have y equals. All All right, so basically this is what we want to graph. Y equals cosecant 2x. Okay? Cosecant is the reciprocal of the sine, so we use that to guide us. I will not tell you on the test, to use the graph of sine to graph cosecant. I'll just say graph cosecant. Okay, the period is going to be 2 pi over b, which is 2 pi over 2, so just pi. Okay, yes. It's easiest to do that, yeah. But you know how to graph sine, and then it's easiest, once you graph the sine, you do the cosine, you do the cosecant. No.
Like, are you going to give us the equation?
No, it's the same though. Whatever the sign is, so for example, if it's y equals 3 cosecant, 4x, then you just use 3 sine 4x. It's the same. Okay, so here, because we already know how to graph the sine, I just graphed it for you, okay? And then we're going to use that to graph our cosecant. Now, wherever sine is 0, I have asymptotes. You have to put those asymptotes. We won't graph this much usually. It'll just be a period or so, okay? And then, on top of this, we now graph our cosecant. So it's going to look like this. It is very important that here at the maxima and the minima, these two graphs are touching, right? You can't leave a gap in between. There. All right, so I've drawn this over a period of 2 pi, but we'll normally just go with one. Over 2 periods, but we'll normally just go with 1 period. Give me just 1 second. So here my asymptotes are at 0, plus or minus pi over 2, and pi. So x equals 0, x equals plus or minus pi over 2, x equals plus or minus pi. Okay? Yes. Wait, yeah.
So why is there asymptotes on each one and then do it? Like the point, like where the vertex is, can you just find that and then just graph it? Like wouldn't it take a lot longer to find the whole?
Well, you need to find the asymptotes as well.
Right.
Right? Yeah. Let's do this next one, and you'll know exactly how you're going to do it from beginning to end. So we're going to graph negative secant 2x. Secant is the reciprocal of cosine. So we're going to use y equals negative cosine 2x. Now the period is going to be 2 pi over 2 again, which is pi. So here we're going to go from 0 to 2x to 2 pi. Now in this case, technically it's a cosecant, so we have asymptotes. I just do open inequalities. It really doesn't make that much of a difference. It's for us anyway, right? Okay, so this is going to go from 0 to x to pi. Now, check out how this looks. Okay, in the case of the cosine, it's going to be a little bit different. Because if we're going from 0, 1, 2, 3, 4 to pi, so I know that the center here is pi over 2, pi over 4, 3 pi over 4, right? And what is my, the amplitude is 1. And actually what I'm going to do is I'm going to double up here. So I'm going to make this a 1 and this negative 1. Because a is negative 1, my cosine is going to start here, go up to 0, maximum, 0, minimum. Because it's negative cosine. It's negative cosecant of x. So here, that's what that looks like. Now when we draw the secant on top of this, the like the U shapes on the edges are gonna be like half U's, which is not really very proper to do. So what we do for this case is we continue a little bit more until this goes back up here, right? So if they're going up by pi over 4s, and if this is pi, then what's the next one going to be? It'll be pi plus pi over 4. How much will that be? 5 pi over 4. And the next one? 3 pi over 2. Okay. All right, we don't need to go that far anyway. So here, it'll go back up to 0, and it'll look like that. Is that correct? Okay. So now, look at what we're going to do. No, look, we're only going to go one cycle. Here, I draw an asymptote. Here.
Isn't that 0?
Huh?
The asymptote is 0.
No, it's where the cosine is 0. It's where the cosine is 0, right? Yes. It's math, of course it makes sense. Okay? So now, on this, I draw my secant, and it looks like that. Okay? Same. Yeah.
Is there a way to find the asymptotes without like finding the point on the graph?
Yes. The way you find the asymptotes up here, if it's secant of x, then you set the term bx plus c equal to negative pi over 2 and 3 pi over 2. It gets to be too many things for you to remember. At the end of the day, you're going to be graphing these, right? So you're going to have to do all of that anyway. This, it's so much simpler, trust me. Okay? All right. Had we not drawn the other part of this, had we not drawn the other part of that, it would have looked like this. So here's what it looked like, right, before. Had we not continued it, it looks like this. Here we get a full secant, or here we get a full U, and then here we get like 2 little U's. And that's only, it's too truncated, it's too cut off. So we don't like that. That's why we want to continue a little bit more. And in order to make everybody on the same page, continue on the right-hand side so that everybody's graph looks the same. Okay? All right. So I have that problem here. So if we wanted to look at the period, it's going to be pi over 2, right? That number, pi over 2. Okay. So let's see. We're going to take 2x plus pi over 2 and bound it between negative pi over 2 and pi over 2. So now, if I subtract pi over 2 from everywhere, here I get negative pi less than x less than 0, 2x, sorry. And if I divide by 2, then I get negative pi over 2, 0. Okay? So here is negative pi over 2, 1, 2, 3, 4, 0. Let's see how much phase shift was. So if I were to ask you to find phase shift, right? You would say, you would take 2x plus pi over 2, set it equal to 0, 2x equals negative pi over 2, x is negative pi over 4. Yeah. Oh, same. Yeah. Same. You get the same answer, right? Yeah. Okay, so let's graph. Yeah. For the asymptotes, to find the asymptotes, you do that. Yeah. But with the inequality, we find the asymptotes in a more efficient way. Okay, yeah. No, it's the absolute value of B. It's the absolute value of B. Okay. So now there is a vertical shift here of 3, right? That means the center point, instead of it being on the axis here, it's going to be moved up 3 units. Okay? Yes? Now, normally for the tangent, it goes up to the right. Why? Because this region from 0 to pi over 2, that corresponds to the first quadrant again. So it's going to be positive on the right and negative on the left. Here, though, we have A is negative 2. So on the right, it's not going to go up 2, it's going to go down 2, and then it has to go up 2 over there. So it looks like this. Okay? Be careful about graphs that look like this. I often have tangents that look like that, but that is not a tangent. That is a pretty sign. Okay? Yes?
So I'm confused what happened with this ratio. Like you found it and then...
Right. So the phase shift, basically this whole graph moved over pi over 4.
So where would it have been if there wasn't a...
Since it's 2x, it would have started at negative pi over 4. But now it moved over even further and it's starting at negative pi over 2. Okay? All right. Yes.